Welcome back, Algebra 2. We're in Lesson 122. We're going to talk a little bit about one of the laws of logarithms. We remember that a logarithm is just an exponent. We know that 100, oops, I don't know why I have my red pen on. Let me go back to the black pen. I like it better. We know that 100 is just 10 squared, right? So the logarithm of 100 to the base 10 is 2. And we know that the logarithm of, the exponent of 1,000 is 10 cubed. So the log there would be the log of to the base 10, or the log of 1,000 to the base 10 would be 3, right? So because of this, because we know we can do this with our exponents, we have 10 squared times 10 cubed, we can get 10 to the 5th, because we're just adding these exponents together. We're getting 10 to the 2 plus 3 as an exponent. We can do that with logarithms as well. We can say log of 100 times 1,000 to the base 10 is going to be written like the log of 100 to the base 10 plus the log of 1,000 to the base 10, because we know that that is the same thing here. This would be 2 and this would be 3, and the base 10 is just this number here. Right, so if we let b, the letter b, represent the base, so that would be here, the base is 10, and let m represent 100, so b squared would equal m, right? Or actually, I'm sorry. We let that equal 100. We put in a as the exponent, and we let n represent 1,000. We could say b is the base times some other exponent is equal to the second value, but they have the same base. Then we can write that statement as, or that rule as, the log to base b, whatever that base might be, with m times n is equal to the log of the base times m plus the log of the same base n. It's the same thing we had up here. We're just using variables instead of actual numbers, and we're doing that to illustrate this, to give you a rule that you can go by when you want to identify. All right, so using the same ideology here with logarithms, we can apply that to our negative exponents and our division, and this is the multiplication. We can apply that to division as well. So we're going to use the numbers to illustrate the rule for the logarithm of a quotient. We can write 10 over 5, 10 over 3. We know that that's going to be 10, 5 minus 3. We understand that because when we move this up to the top, this becomes a negative exponent. So 5 minus 3 would be 10 to the 2. So we can actually write that as a logarithm like this. We'd say log the base 10. We would have 5 zeros up here, if I can write 5 zeros correctly, over 3 zeros in the bottom. And that would equal the log with a base 10 of 100,000 minus the log of 1,000 to the base 10. It's the same thing we did here. we're just writing it, the exponent, as a logarithm, because that's all a logarithm is. It's just the exponent. So the exponent of 5 minus the exponent of 3 to the 10 base. That's all we're doing. So if we replace all of this with the letters we described above, we would write that rule like this. The log of b with m over n is equal to, I keep wanting to do this lowercase for some reason, the log of m to the base b minus the log of n to the base b. And that would be your rule for that, for the division. So that's your format. That's the way you can split it up and look at it. So write these two down and keep them in your notebook, handy reference, so that you can understand what's going on. And if you want to, put this illustration next to it. Actually, just write all of this stuff down in your notebook. Put this where you can reference it quickly. But this is going to illustrate this for you, because this is going to show you 5 minus 3, what that actually is here. All right, moving on. Let's look at intersection of sets. So let me clear the page, and we'll talk about that. No, we're not going to do any problems with logarithms today. So if we have two sets, let's say we have A is equal to this set, 1, 2, 3, 6, and 7. And we have another set B, and it is equal, or it contains the members of 1, 3, 8, and 9. We see that the numbers 1 and 3 are members of both sets. So we say that the set 1, 3 is the intersection. So that's the intersection. That's what we want to talk about. And apparently I cannot write well this morning. That is the intersection of these two sets are the members 1 and 3. We use the symbol that looks like this. It's like an upside down U, but wider, like an upside down half circle, to represent the word intersection. So what we do is we write the intersection of A and B is equal to 1 and 3. And it's read as the intersection of sets A and B is equal to 1 and 3. We see that the intersection of two sets is the set whose members are members of both of the given sets. And that is what you want to include. So put all this in your notes so you can understand intersection, and that this is the symbol that we use for it. This is what you're going to want to do. So we have a practice problem with this. And let me write that down for us, because it's going to take me a minute. All right, so in this example problem, it says given that P equals 1, 2, 3, 4, 7, 9, and 13, and K equals 2, 5, 7, 8, 10, 13, and 15, find the intersection of sets P and K. All right, so the intersection of sets P and K is equal to, well, 1 is not a member of both sets, but 2 is, 3 is not, 4 is not, 7 is, 9 is not, but 13 is. That is so easy. That's it. That's your answer. The intersection of sets P and K is 2, 7, and 13. All right, so that's all we have for intersection of sets. Let's talk about the union of sets. So let me put set A here is equal to 1, 2, 3, and 7. Let me put a line here so you don't get confused. This is something different. And B is equal to 1, 3, 8, and 9. We list all the members of both sets. If we listed all the members of both sets, we would write 1, 2, 3, 7, 8, and 9. And we use the set notation. We just write the numbers once, right? This set is called the union of sets A and B. And to write the union of sets A and B, we write the same symbol but upside down. So A, the union of sets A and B, equals this. So this is all the members of sets A and B together. This is the intersection, so these are just the members that are both, that are in both. These are all the members of both, whether they're in A or B, it doesn't matter. We're putting them all together. And remember, when you have a duplicate, you just write it once when you use set notation. So remember, this means intersection, right? This means the union of. Those are your two new symbols when it comes to set notation. Fun stuff. All right, so let's move on to Venn diagrams. This is where we get to use those, right? So I'm going to take a second and draw a diagram up here for you. All right. This diagram is what we call a Venn diagram. A Venn diagram is where we have two circles that overlap, and the overlapping information is important. It shows us where the two sets collide. It's where they contain the same information and have a relationship. Diagrams can be used to enhance our understanding of the intersection and union. In this diagram, we've designated set A here. This is set A. And we've designated set B as this circle, right? So we have the numbers 15 and 17. We can see are members of both sets A and set B. So these numbers are the intersection of sets A and B. We could actually write a couple of different things here. We could say, all right, A is equal to, and then we'd write the numbers that are in set A, and that would be 6, 7, 8, 9, 13, 14, 15, 16, and 17. And the members of set B would equal 15, 17, 20, 21, 22, and 23. Those are the members of the sets. Now we can write that the intersection of A and B, so A, the intersection of A and B is equal to 15 and 17. And then we could write the union of A and B, it's the upside down, the cup. Think of it as a bowl that holds all the numbers. And this is just a bowl turned upside down to hold the two together. That's going to equal all of the numbers in the set. And so that is going to be 6, 7, 8, 9, 13, 14, 15, 16, 17, 20, 21, 22, and 23. All right, easy peasy. So everything within both circles for the union of the set, and just where the circles overlap for the intersection of the set. And that should illustrate that just a little bit more for you. I'm going to clear this page. So pause it if you want to write this down as an illustration of those things. But I'm going to clear it and I'm going to put our next problem on the board. All right, in this problem, it gives us a Venn diagram. And it tells us the circles contain the members of sets A here, sets B here, and C here. And it wants us to designate the areas below. So I'm going to do that with color. So this is going to be the intersection of A and B. So the intersection of A and B, I'm going to do that in this green color here. where A and B intersect is going to be right where these two circles overlap. So that's the intersection of A and B. All right, so then it says to designate the union. That's a U for union. You can think of it like that. That's kind of neat. So the union of B and C. So I'm going to use yellow for that. So the union of B and C would be all of C and all of B. So both of those circles. So all of that. So now I'm going to choose this kind of gray color here, and it says to indicate the intersection of B and C. So I'm going to use this little gray color. So the intersection of B and C is going to be just where B and C overlap each other. Just that little part right there. All right, and that would be the answer to all of those. And that is all we have for lesson 122, and I will see you in lesson 123.